Fun Science with KidBright. This episode will feature Little Programmer and the application of KidBright. Okay, young programmers and kids, after we've learned a lot on how to use KidBright, we now have a mission for you. The first mission is the KidBright Invader Battleship game, or in other words, a mission to create a battleship game. As for mission number 2, you will have to create notification through the Line application with the KidBright Line Notify mission. And the last mission is the KidBright IFTTT Webhooks, which will collect data from KidBright and then send it to Google Drive. So, let's not wait any further and proceed to each mission. Mission number 1. Creating the KidBright Invader Battleship game. Kids, let's create the KidBright Invader Battleship game. In this game, the player controls the ship to avoid the enemy's ammunition. The required equipments include a computer, a KidBright board, and a micro USB cable. Next, we must create coding on the KidBright IDE. First, download the plugin.display. The plugin can be downloaded at worldwideweb.kid-bright.org. Select Download and scroll down to find the plugin named .display plugins and then click Download. Install the plugin. Run the KidBright IDE. Click the Plugins button and then select Install Plugins. Select the downloaded file and click Open. The KidBright IDE program will be automatically closed and reopened again. This means that the plugged-in installation is complete. Next, we have to create a set of instructions. We will divide our program into 3 parts, namely our ship, the enemy ship, and the ammunitions. Let's begin with our ship's instruction by using the task block and rename it to My Ship. Next, define the point where our ship will first show up by using the set variable block, for which we need to rename the variable name to my_x and set it to 0. Use the forever block. Then, write code for button 1 of the KidBright board so the ship can move to the left. Drop the if, do, else block and then plug the switch 1 pressed block into it. Then attach the repeat block to the do slot of the if, do, else block, like this. Next, put another switch 1 pressed block into the repeat block in order to enable the ship to move each time button 1 is pressed. Then add a .display block to the if, do, else block located under the repeat block like this. To set the position X, add a variable block and then select my_X to set the position Y. Add a constant block and then set it to 0. Doing so, our ship will be at the bottom line of the LED screen on the KidBright board. Next, select Unplot in the type box so that our ship will disappear when the button is pressed. Add another set block, the name of which is set to my_X. And then plug a math arithmetic block into it. Having my_x minus 1, this is to set my_x equal to my_x minus 1, so our ship will shift left by 1 dot each time button 1 is pressed. In order to prevent our ship from going off the edge of the LED screen, use an if-do block to compare if my_x is less than 0 or not. If yes, set my_x to 0. Next, let's write code for button 2. attaching an if do block to the else slot of the if do else block, and then plug the switch to pressed block into it. Then attach the repeat block to the do slot of the if do block like this. Next, put another switch to pressed block into the repeat block in order to enable the ship to move each time button 2 is pressed. Then add a dot display block to the if do block located under the repeat block like this. Then set the position X and Y and type to the same setting as done for the previous dot display block. Add another set block, the name of which is set to my_x, and then plug a math arithmetic block into it, having my_x plus 1. This is to set my_x equal to my_x plus 1, so our ship will shift right by 1 dot each time button 2 is pressed. In order to prevent our ship from going off the edge of the LED screen, use an if do block to compare if my_x is more than 15 or not. If yes, set my_x to 15. Next, add a dot display block to the forever blocks. Set it like we have done before. Except that its type is set to plot. This way, our ship will show only when the button is released. Now, connect the KidBright board to the computer. Build and flash the program onto the board. Try pressing button 2 to see if the ship moves to the right or not. Wow, that's great! Now let's try pressing button 1. Does the ship move to the left? Oh, that's right. Now, we are going to write blocks for our enemy ship. Kids, you can start writing a set of instructions following this example. The enemy ship will keep following our ship along the opposite side of the LED screen. Rename the variable INV_x, which represents the enemy ship's X position, and then set it to 0. Next, check if INV_x is greater than my_x or not. If yes, the enemy ship will follow our ship to the left. The enemy ship always stays on top, so the Y position is set to 7. Next, check if INV_x is less than my_x or not. If yes, the enemy ship will follow our ship to the right, similar to the blockly code of our ship. Now, for the ammunition, we need to set its X position. Use the variable missile_x, which is then set to INV_x, and we need another variable launch_flag, which is then set to 1, meaning the ammunition is ready to get fired. Next, plug the dot display command block to the forever block, then set its X and Y positions to the INV_x variable and 7, respectively, and the type is set to plot, so the enemy ship will be displayed on top of the LED screen. Set the delay to 0.1 second. After that, let's write the ammunition code. Kids, you just follow me. We need the ammunition to be fired from the enemy ship towards our ship. When an ammo hits our ship, there will be a warning sound. Next, connect the KidBright board to the computer. Build and flash the program to the board. Now, let's try it. How was it? Wow! Oh! Wow, that's great! Oh, very good! Mission 1 has been completed. Here we go, your supercomputer. Now kids, let us continue your mission. Mission number 2. Creating an alert using KidBright Line Notify. Let us enable the KidBright board to send notification to the Line application using the Line Notify plugin. First and foremost, we have to prepare various devices, which includes a computer, a KidBright board, and a smartphone. First, download the plugin. The plugin can be downloaded at worldwideweb.kid-bright.org. Select Download and scroll down to find the plugin Line Notify. Go to store.kidbright.info. In the Communication group, scroll down to find the plugin Line Notify and then click it. You will find the information page about this plugin. Line Notify will allow us to send messages and stickers through the Line application. Scroll down to the bottom of the page and download the Line Notify v1.1. Let's install the plugin. Open the KidBright IDE, then click on the Plugins tab and select Install Plugins. Select the downloaded file and click Open. The KidBright IDE program will automatically be closed and reopened again, which means that the plugin installation has been completed. Next, we are going to set up the Line application. Going back to the Line Notify page, scroll up to the topic of usage. Use your smartphone to scan the QR code and add Line Notify as a friend on your Line application. Next, click on the link notify-bot.line.me/mine/ to log in with your Line account. If you don't have one, just sign it up. After logging in, our Line account will appear on the top right corner. Scroll down and click the Generate Token button. Next, enter the name that we want to display when sending notification via the Line application. After that, choose a chat where you will send notification messages to. A notification can be sent to a chat which can be either your own Line ID or a group. Next, click on the green button below to generate a token. Then, copy the token which will be used on our KidBright IDE. Returning to our KidBright IDE, under the Line Notify plugin, select and drop a Set Access token to block. Then drop a text block and paste the token key copied previously into it. Next, attach a forever loop block to the Set Access token to block. Let us set working conditions, such as when we are not at home, KidBright will notify us when a door is being opened by an intruder. To do so, drop an if do block and plug a switch 1 pressed block into it. Then append an LED 16:8 scroll when ready block to it. Add a text display block where we can state a notify message. Then, plug a send notification block into do slot. Add 5 text block to the sent notification block. For the message slot, type a message you need to send in its text block. For the other slots, you might leave their text blocks blank if you don't need to send anything else. For those who want to send stickers as well, go back to the Line Notify Plugins website. Here is their explanation. To send a sticker, both the sticker package ID and sticker ID must be submitted. Click on the sticker list to have a look like this. Then find a sticker that you want to send from the table in which the first and the next column contains the sticker ID value and the sticker package ID respectively. Insert the numbers selected from the table to our text block. Next, set up Wi-Fi for our KidBright board by clicking on the Wi-Fi button. Specify the SSID and password and then click OK. Add the delay block in order to delay the notification for 2 seconds. Next, connect our KidBright board to the computer. Build and flash the program to the board. When the KidBright board is connected to Wi-Fi, a red light on the board will light up like this. Let's test it by pressing button 1. Oh, you have succeeded! It is showing an alert. Kids, you can apply it to other applications such as an incubator. If its temperature is too high or too low, it can notify us immediately so you can do something for it. Great! Mission 2 has been completed. Get a super smartphone as your reward. Don't wait, let's move on and do the next mission. Mission number 3. The KidBright IFTTT Webhooks. Okay, the IFTTT Webhooks plugin can be installed on the KidBright board to forward data to other services such as Facebook, Twitter, or document files on Google Drive, and so on. Let's try it. All you need is a computer and a KidBright board. First, download the plugin. The plugin can be downloaded at worldwideweb.kid-bright.org. Select Download and scroll down to find the plugin named the IFTTT Webhooks. Go to store.kidbright.info. In the communication group, scroll down to find the plugin IFTTT Webhooks and then click it. You will find the information page about this plugin. Scroll down to the bottom of the page and download IFTTT Webhooks v1.0. Let's install the plugin. Open the KidBright IDE, then click on the Plugin tab and select Install Plugins. Select the downloaded file and click Open. The KidBright IDE program will automatically be closed and reopened again, which means that the plugin installation has been completed. Next, we are going to set up the IFTTT Webhooks in order to enable the KidBright board to send data to Google Sheet on Google Drive. First of all, you must apply for an IFTTT membership by clicking on the link ifttt.com/discover. Click on Sign Up, where you can choose either your Google or Facebook account. Here, choose your Google account, then enter your email address. Click Next and enter your password. Click Next. From there, a web page will show up, telling us to choose service that we usually use. We may skip it by clicking the cross. Next, select My Applets on the top left of the screen. Click on the new applet on the right side of the screen. Click plus this. Type webhook in the search box and click the webhooks icon. Then click Connect. Click Receive a web request. After that, name the event in the event name box. Here, we will be collecting temperature values, so let's name it temp_log and press the Create Trigger button. Then click plus that. Type Google Sheets in the search box. Click on the Google Sheets icon. Then, click Connect and select the Google account that we will use, and then allow IFTTT to access our Google account to view, create, or edit information on our Google Drive. Next, select Add Role to Spreadsheet and then name the file in the spreadsheet name box. Here, let us name it as Outside Temperature. Go to the Formatted Row box and click on Add Ingredient and select Occurred At. And click Add Ingredient again and choose Value 1. From the Drive Folder Path box, specify the location of our log file on Google Drive by typing temp log/outdoor and click Save. After that, a summary message will pop up. If a temp_log event occurs, it will create a new row of text on the spreadsheet of Google Drive. Then click Check Now to test. Click on Webhooks. Click on Documentation. Copy the key to be used in KidBright IDE. Now, scroll down to test whether the data can be sent successfully or not by entering the name temp_log into the event box. Then put a temperature value into the value 1 box and click the Test It button. The system will send this data to the Google Drive. Next, check your Google Drive to see if the data transmission is correct or not. Wow! Found it, and it's correct! After that, we open KidBright IDE, choose IFTTT Webhooks plugged in, and then attach a tag block to the key slot. Press Ctrl+V to paste the key value that you copied from the IFTTT website into the text block. After that, append a text block to the event name slot and type temp_log. We need collect temperature data, so we connect a temperature sensor block to the value 1 slot. The value 2 and value 3 will not be used, so just attach blank text block to them. To keep running the block, we need to use a forever block. To show the read temperature value, plug a LED 16:8 scroll when ready block followed by a temperature sensor block into the forever block. Then, add a delay block in order to delay the data collection. For example, every 15 seconds, the time in the delay block is in units of seconds. If you prefer a number in minutes or hours, don't forget to convert it to seconds. Then, get your KidBright board connected to your Wi-Fi by clicking on the Wi-Fi button. Then, specify your SSID and password and click OK. Next, connect the KidBright board to the computer. Build and flash the program to the board and click OK. When the KidBright board is connected to the Wi-Fi, the red light on the board will light up like this. Oh, you got it! A temperature value is being shown on the LED display. Put your finger onto the temperature sensor. See? The temperature is rising up. Now, let's see the data we sent over the internet onto Google Drive. Here it is. You've successfully done it, kid. You may apply it to various applications. so your data will be more useful. Example, you may analyze data like finding its progression and its minimum and maximum value, or find some correlations. Wow, very awesome! Mission 3 is now done. Get this, Programmer Olympic Gold Medal. Now, you have built a reputation around the world. Very good. Keep developing your skills. You kids are all very talented. Don't forget to follow the next clip, everyone.